Most of us these days use nanotechnology and nanoparticles on an hourly basis. Consider that every time we use our cell phones or computers, we are taking advantage of nanoparticles. But applications of these particles are not limited to electronics. On hot summer days, we take advantage of nanotechnology in our sunscreens. And in medicine, these particles are used to slow the growth of advanced cancers and can help destroy tumors in our bodies. But first, let's try to get a better understanding of what a nano-sized particle really is. This video can help us get a better perspective of really how small a nanoparticle is. As we see in this animation, to get a good understanding of the size of nanoparticles, we have to zoom our view thousands of times to be able to grasp a better understanding of their extremely small size. At this size, particles are so small that they start to have strange and unexpected properties and behave different than what we would expect of them normally. What you see in these images are spheres of nanoparticles that can only be seen by very high-resolution microscopes. Now that we have a better idea of their size, we wondered, what exactly are they? Where do they come from? And how are they made? To find out more, we approached one of the leading researchers in this field to find out about their team's accidental discovery of gold nanoparticles.
I'm Mark McLaughlin. I'm a professor of chemistry at UBC. I've been a professor here for 15 years. So we've been studying plastic films that have a spiral of holes inside of the film. So with this spiral of holes, we wanted to incorporate gold nanoparticles to see whether or not they could communicate and know they're inside of a spiral. And the usual way to do this is you combine a gold salt and a reducing agent. And what we discovered was that when you add the gold salt, the gold gets reduced to gold nanoparticles without the reducing agent. You don't need the reducing agent. And this was a really surprising discovery for us.
This meant that nanospheres were spontaneously formed containing traces of gold inside them. The gold can be seen in this image as dark dots inside the nanoparticles. When visiting Dr. McLaughlin's lab, we can get a tangible understanding of what these particles look like.
Hey, my name is Andy. I am a PhD candidate in the McLaughlin lab, and we're based here at UBC. And today we're going to be talking about nanoparticles. You're probably wondering, well, what nanoparticles are. And contrary to what you're thinking, it's just this cool little red-looking solution. And what I'm holding here is actually a gold nanoparticle solution. And how you make it is quite easy, actually. So if we go through, we're going to have some sort of beaker here. We're going to fill it with what we're going to call precursors. And the precursors is essentially the things we need before we actually make gold nanoparticles. And what we're going to do is we're going to simply throw in some gold compound, so this AU, which is also known as gold, this is just the element for it. And once we throw it in, what will happen in this beaker is just we're going to get these little things forming. And as the reaction continues, we're going to grow them a little bit bigger, until finally, at the end of the reaction, we're going to have what are known as nanoparticles. And nanoparticles are called nanoparticles because they're very small and they're on the nanometer size.